Our solar system is a busy place. You've got planets, moons, asteroids, comets. It's our cosmic neighborhood. We know the neighbors pretty well, but every so often a visitor from another star system drops by. An interstellar object, a true cosmic messenger. They carry secrets from distant suns we've only dreamed of reaching. They are drifters, hurled from their home systems by gravitational tugs of war. Enter the James Webb Space Telescope, or JWST for short. This isn't just another telescope, it's an engineering marvel, a testament to human curiosity and ingenuity. Stationed a million miles from Earth, far from the distorting haze of our atmosphere. Its giant golden honeycombed mirror is designed for one primary purpose: to see the universe in infrared light. Why infrared? Because that's the light of the cool, the distant, and the old. The universe is expanding, and as light from the very first galaxies travels across billions of years to reach us, its wavelength gets stretched out. The JWST is the ultimate cosmic detective. Its sensitivity is breathtaking. It can detect the heat signature of a bumblebee on the moon. Think about that for a second. This power allows it to analyze the atmospheres of planets orbiting other stars, exoplanets, searching for the chemical fingerprints of life, water, methane, oxygen. It can watch planets being born from swirling disks of protoplanetary dust. It is designed to answer some of the biggest questions we have. Where did we come from? How did the universe begin? And of course the big one, are we alone? So, when a new interstellar visitor like 3I Atlas appeared, you know what happened. The world's astronomers scrambled to get time on the best instrument we have. Point the Webb at it, let's see what this thing is made of. The plan was simple. Use JWST's powerful spectrographs to break down the faint light reflecting off Atlas's surface. We expected to find signatures of water ice, silicates, or maybe some organic molecules. Standard stuff for a comet-like object. But what JWST saw was far from standard. It was something that sent shockwaves through the astronomical community. The observation of 3I Atlas began like any other. The telescope locked onto its target, a barely there pinprick of light, moving against the fixed background of distant stars. The instruments began collecting photons, the tiny particles of light that had traveled for who knows how long from this cosmic wanderer. The data streamed back to Earth, to the Space Telescope Science Institute in Baltimore. Scientists watched their screens, ready to begin the painstaking process of analysis. They were looking for the faint, continuous spectrum of reflected sunlight. But that's not what they got. Not entirely. Instead, superimposed on the weak solar reflection, there were spikes. Brief, intense, and distinctly non-random flashes of light. These were not the gentle, predictable outgassing jets of a comet, which would show up as a fuzzy, expanding cloud of gas and dust. These were sharp, localized, and periodic. They blinked, like a lighthouse in the cosmic ocean. The team checked their instruments. They checked for sensor noise. They checked for cosmic ray hits. They ran every diagnostic they could think of. The signals were real. They were coming directly from the surface of 3I Atlas. The pattern was what truly baffled everyone. The lights weren't chaotic. They flashed in a complex but repeating sequence. It was a structured signal pulsing with a mathematical regularity. Imagine walking on a deserted beach and finding a rock that flashes SOS in Morse code. The feeling in that control room must have been a similar mix of disbelief, excitement, and a little bit of fear. This was not the signature of any known natural phenomenon. Not outgassing, not volcanism, not a simple reflection from a spinning, faceted surface. The news spread like wildfire through private channels and secure email chains, long before any public announcement. The discovery was too monumental, too sensitive to release without triple and quadruple checking every last piece of data. Teams around the world reanalyzed the raw telemetry from JWST. Other telescopes, both on the ground and in space, were quickly pointed toward 3I Atlas. The verdict was unanimous. The lights were real, they were structured, and they were coming from an object that originated far beyond our solar system. The question on everyone's mind was no longer what is it, but who made it. Before we jump to little green men, science demands that we exhaust every possible natural explanation. The universe is a weird and wonderful place, and it has thrown us curveballs before. So what could cause a natural object to blink with such a strange regularity? The first and most obvious suspect is some kind of geological activity. Perhaps 3I/Atlas is not a solid, inert rock. It might have a unique composition that causes pockets of volatile materials to flash freeze. Those pockets could then explosively sublimate when sunlight hits. All of this happening as the object tumbles. Think of it like cosmic geysers. As the object rotates, different parts of its surface are exposed to the sun. If certain areas contain highly volatile ices, solid nitrogen, carbon monoxide buried just beneath a dark crust, solar warmth could cause a sudden pressure buildup. That pressure can burst through a weak point, releasing a jet of gas or ice crystals. If funneled through a focused vent-like structure, it could show up as a brief, intense flash of reflected sunlight. Another possibility: exotic mineralogy and static electricity. Imagine the surface covered in crystals with piezoelectric properties. They generate electrical charge when compressed or stressed. As the object tumbles through space, tidal forces from our sun, tidal forces from planets, even if weak, could cause minute stresses. That could generate powerful static discharges, essentially lightning storms on the surface. This isn't the first time we've been left scratching our heads. The story of 3I Atlas immediately brought to mind Oumuamua. Discovered in 2017, Oumuamua was bizarre. It was highly elongated, maybe 10 times longer than it was wide. As it sped away from the sun, it gently accelerated, pushed by some unseen force. Avi Loeb proposed a more radical idea. What if Oumuamua was an artificial object, a piece of alien technology, perhaps a solar sail? And speaking of messages, who can forget the WOW signal? In 1977, the Big Ear radio telescope picked up an incredibly strong signal for 72 seconds. The signal was so striking that Jerry Amon circled it on the printout and wrote "WOW" next to it. It had all the hallmarks of a possible extraterrestrial broadcast, but the WOW signal was never heard again. Decades of searching found no repeat. Like Oumuamua, the WOW signal remains unsolved. It reminds us that we are still cosmic infants. The universe is full of unexplained phenomena, and 3I/Atlas now joins that tantalizing list, pushing our imagination and our science. So, you've detected flashing lights on an interstellar object. What do you do next? You don't just jump to conclusions, you follow the evidence. The first step in this grand detective story is to gather more data. Lots more data. Every available telescope on and off the planet is now locked on 3I/Atlas. We need to observe it across the entire electromagnetic spectrum. The JWST is watching in infrared, Hubble is looking in visible and ultraviolet, and radio telescopes like the Very Large Array are listening intently for any radio emissions. Each type of observation gives us a different clue. The infrared spectrum from JWST can tell us the temperature of the lights. Are they hot, like an engine exhaust, or cool, like an LED? Analyzing the light's polarization can tell us if it's being reflected off a surface or generated directly. High-resolution imaging attempts to resolve the object's shape and pinpoint the exact location of the flashes. Are they all coming from one spot or from multiple symmetrically placed locations? The radio telescopes are listening for any leakage, any stray signals that might betray the presence of machinery or communication systems. The second phase of the investigation is modeling and simulation. Scientists are running countless computer simulations to test the natural hypotheses. Can they create a model of a tumbling, outgassing comet that perfectly reproduces the observed flashing pattern? Can they design a configuration of natural crystals and static electricity that blinks in just the right sequence? They will tweak every variable: the object's shape, its rotation speed, its chemical composition. Science progresses by trying to break its own theories. If every natural model fails to replicate the data, the alternative hypothesis, the artificial one, becomes stronger. This process is slow, meticulous, and collaborative. Papers are published, peer-reviewed, and debated. Different teams propose different models. Some will argue fiercely for a natural explanation. Others will argue that the simplest explanation is that the pattern is too complex to be coincidence. This is the scientific method in action. Rigorous, self-correcting, driven by evidence, not wishful thinking. The stakes are too high for anything less. Every natural avenue must be explored and sealed off before we dare to walk through that other door. Let's allow ourselves to wonder for a moment. Let's say we've exhausted all the natural explanations. The geysers don't match, the lightning doesn't sync, the reflections don't work. The data points one way: the lights are artificial. Science fiction's century-old dream becomes testable reality. Humanity looks up, and for the first time, we're not alone. Implications ripple across society. What could 3I/Atlas be? An automated probe, a von Neumann probe, self-replicating, one of billions from a long-dead civilization, lights as propulsion, lights as scanners analyzing our system, a derelict ship, emergency lights blinking, a message in a bottle, a cosmic archive carrying knowledge and art. A seismic philosophical shift would follow. Religions would have to contend with this new reality. Philosophies would be reframed. Our sense of self would be challenged. It could unite humanity, or it could trigger fear and paranoia. And then come the practical questions. Do we try to communicate? How? The lights are blinking in a complex pattern. Is it a language? A mathematical primer? A map? Mathematicians would be mobilized? Linguists would be mobilized? Artists would be mobilized? Do we try to intercept it? 3i/Atlas is racing back into the void. A chase mission. Global, unprecedented. This discovery wouldn't be an endpoint. It would be the beginning of the most profound conversation in history. Whether the lights on 3i/Atlas turn out to be a strange natural phenomenon or the handiwork of an alien intelligence, the quest to find out is what truly matters. This is what we do. We are explorers. We are pattern seekers. We are a species defined by our insatiable curiosity. From the moment our ancestors first looked up at the stars and wondered what they were, we have been on this journey. Every myth, every telescope, every space mission. This discovery is not an anomaly. It is the culmination of that ancient human impulse. The search for life beyond Earth is one of the most profound scientific endeavors we can undertake. It holds up a mirror to ourselves, forcing us to ask fundamental questions about life, intelligence, and purpose. The universe is immense with 2 trillion galaxies, hundreds of billions of stars, planets around stars. In the face of such numbers, the idea that we are the only ones seems, to me, statistically unlikely. But belief is not science. Science requires evidence. And the potential evidence now blinking at us from 3i/Atlas is exactly what we've been looking for. This is a moment of pure wonder. Forget for a second about the technical details and the scientific debates. Just think about it. An object born in another solar system that has traveled through the dark for millions of years has entered our home. And it is flashing. It is calling attention to itself. It challenges us to look closer. Think bigger. Be prepared for an answer we might not expect. This is the essence of discovery. It's not about confirming what we already know. It's about confronting what we don't. It's the thrill of the unknown, the joy of the puzzle. So, we will continue to watch. We will continue to analyze. We will continue to ask questions. Because no matter what the final answer is, the journey itself will have changed us. It will have pushed our technology, expanded our knowledge, stretched our perspective. We are living in an age of unprecedented discovery, where the tools we have built are finally powerful enough. The story of 3i/Atlas is the story of humanity reaching out into the great cosmic dark, holding a candle, and hoping to see another candle flicker back. And maybe, just maybe, we have. To begin answering the questions our ancestors could only dream of asking.